Hi guys, this is lesson 1 in unit 2 and it's about solving equations. Let's start with this simple example. We have one step equation and we have 3x equals 21. So we're trying to solve this equation by looking at the operations that we have on the left side and what we can do to isolate the x by itself. We have 3 times x, which means we have multiplication. The inverse operation or the opposite operation of multiplication is division. So I'm going to divide both sides of the equation by 3, and I'm going to end up with x equals 7. This is an equation. Whatever you do to one side, you have to do to the other side of the equation across the line over the equal sign. So if I divide one side by 3, that means I need to divide the other side by 3 as well. Now let's take a look at two-step equations where we have 3x minus 13 equals 8, and I'm trying to isolate the x. I have multiplication and subtraction. I always start with the weaker operation based on PEMDAS. So subtraction is a weaker operation than multiplication. So in this case, I'm going to have to get rid of 13 by adding 13 to both sides, because addition is the opposite or the inverse of subtraction. And since I'm adding 13 to one side, I have to do the same thing to the other side, which means I will end up with 3x equals 21. Now I have a one-step operation. All I need to do is to divide by 3, because division is the opposite of multiplication, and I end up with x equals 7. Now let's talk about equations that has parentheses. We have 3 times x minus 4 equals 21. We know that when we have parentheses, we need to get rid of the parentheses, and one way of getting rid of the parentheses is by distributing. So I'm going to distribute 3 into the parentheses. 3 times x is 3x. 3 times negative 4 is negative 12. And then after that, I'm going to end up with the two-step equations. We have subtraction and multiplication. I need to start with subtraction by adding 12 to both sides of the equation, which means I'm going to end up with 3x equals 33. This is a one-step equation. The opposite or the inverse of multiplication is division. So I'm going to have to divide both sides by 3, and the final answer is 11. Let's take a look at another equation here this time, but this time we have variables on the same side. So we have 3 times x minus 4 plus 6x equals 21. And to be able to solve this equation, I'm gonna have to get rid of the parentheses by distributing. So I'm gonna distribute 3 into the parentheses. 3 times x is 3x. 3 times negative 12, 4 is negative 12. And then I'm gonna add 6x equals 21. Now, if we look here, we'll see that we have like terms on the same side of the equation. And when we have like terms, we need to combine them to make the side much simpler, to simplify the side. So 3x plus 6x is 9x minus 12 equals 21. This is a two-step equation. I need to add 12 to both sides. which makes me end with 9x equals 33. This is a one-step equation. The opposite of multiplication is division. So I'm going to divide both sides by 9. And the final answer is going to be 11 over 3. Now let's take a look at equations where we have the same variable on both sides. So we have 3 times x minus 4 equals 4x plus 8. To be able to solve this equation again, we're going to have to distribute the 3 into the parentheses. 3 times x is 3x. 3 times negative 4 is negative 12. I need to put my line to define where both sides are equals 4x plus 8. If you take a look at this equation, you'll find out that we have x on both sides, and we're trying to isolate the x. So that means we're trying, instead of having 2x, we need to have just 1x at one side. And the only way we can isolate the x is to move one of these two terms to the other side. So I'm going to move 3x to the other side by doing the opposite operation, because I'm moving that term to the other side of my line. So the opposite of addition is subtraction. So I'm going to subtract 3x from both sides, which makes me end with negative 12 equals 4x minus 3x is x plus 8. So every time I need to move a variable, a term, or a number from one side to the other, I have to do the opposite operation to be able to move it. Now, this is a one-step equation. All I need to do is to take away 8 from both sides, and I'm going to end up with negative 20. And that's the final answer. Now let's talk about equations with ratios. Let's see the first example. We have x plus 6 over 3 equals 8. So we have a ratio equals to 8. To be able to simplify this equation, or to solve this equation easily, I'd rather get rid of the fraction somehow and make it a simple equation. And to do that, we know that fractions are divisions. So 3 is divided by x. I mean, x plus 6 is divided by 3. That means we have a division, and the inverse operation of division is multiplication. So I can multiply both sides by 3 to get rid of 3. And then this will make me end with a simple equation. X plus 6 equals 8 times 3 is 24. Now, this is a one-step equation. All I need to do is to subtract 6 from both sides, which makes me end up with x equals 18. Let's take a look at another example with ratio. We have 3 equals 2 over 5y plus 1. So in this example, the problem will be much easier if I get rid of 1. Because I'm not going to be able to deal with the fraction unless I do something with a 1. We know that 1 is added to the equation. That means to be able to get rid of 1, all I need to do is to subtract by 1 from both sides. 3 minus 1 is 2 equals, now I have the fraction multiplied by the y, and to get rid of the fraction, we can either divide by the fraction or multiply by the reciprocal, which is 5/2, which I think is easier than dividing by the fraction. So in this case, I'm going to end up with 5 equals y. Now let's take a look at this equation where we have equal ratios on both sides. So we have 2/x equals 3/x minus 2. We have ratios on both sides, and the easiest way to deal with this equation is to get to try and simplify the problem, and instead of having ratios, have a simple equation. So in this case, I'm going to have to cross multiply because cross multiplying will allow us to get rid of the fractions. So when I say cross multiply, that means I need to multiply the top of the first fraction, which is 2, by the bottom or the denominator of the second fraction on the other side, which is x minus 2. This side, which is called the product of the means, it's going to be equal to the denominator of the first fraction multiplied by the top of the second fraction, which is the product of the extremes. So now, all I have now is an equation with parentheses that I can simply solve by distributing 2 on both in the parentheses. So 2 times x is 2x, 2 times -2 is -4, equals x times 3 is 3x. Now I have x's on both sides. That means I need to move one of these x's to the other side by doing the opposite or the inverse operation. I'm going to subtract 2x from both sides, which makes me end with -4 equals 3x minus 2x is just x. And that's the final answer.